everyone. I am Rinku Mukherjee from IIT Madras, and I'm going to be offering the course entitled Introduction to Boundary Layers, starting January 2016. A little bit about the course. It's a 20-hour lecture. It's primarily intended for students of aerospace engineering, mechanical engineering, civil engineering, chemical engineering, physics, and slightly for senior level students, third or fourth year undergrad students, and master's and PhD students. And what one would require to really understand the portions that will be covered in this course is basic fundamental knowledge of fluid mechanics. I will, however, do a brief overview of the basic fundamentals of fluid mechanics before I get into the details of boundary layers. So what exactly is so special about boundary layers? Why should you be taking this course? Well, the applications of boundary layer theory, so to speak, is plenty, right? Aerospace applications, nuclear reactors, flows in conveyors, emission of pollutants in refineries, handling of materials, flow through nozzles, diffusers, flow past wings, airfoils, flows at high angles of attack, so on and so forth. For example, even metal casting, when you cast steel rods. So applications of boundary layers are plenty, okay? And I think it's important that before one sort of sets into a career, that you have at least a basic knowledge of boundary layers, and at least know what boundary layers are all about. So the way we'll go about this course is, like I said, we will begin with a review of the basic fundamentals of the fluid mechanics. We will then really spend some time on the concepts involved in boundary layers. What exactly is a boundary layer? There are things like boundary layer thickness, boundary layer displacement thickness, boundary layer momentum thickness, skin friction coefficient, boundary layer separation, so on and so forth. So first of all, we're going to sort of touch upon all of those things and really understand the concepts behind all of this. And next step will be to do the math so that we can get a quantitative measure of what all these things mean, right? So if I say there is a boundary layer, then the question would be, well, how thick is it, or how is it located? Where is it located? And is it going to cause what kind of effect does it have on the flow that I'm looking at? So those are the type of questions that we will be looking to answer, right? So if you, for example, if you say I have a flow which is going through pipes, right? Will we have a boundary layer there? If we do, then what is the effect of the boundary layer? Okay, so those are the type of questions we will be trying to answer. The postulant of boundary layer theory, which is one of highly respected, genius of a scientist, which is Ludwig Prandtl, really came up with the boundary layer theory, like I said. So what we will do is go step by step and look into the derivation of the Prandtl's boundary layer theory, okay? And in order to understand his thought process, and in order to understand that what exactly went through his mind when he postulated the boundary layer theorem, okay? And then we will use this to apply to a flat plate and to other bodies which are other than the flat plate. We will look at boundary layer separation. We hear a lot about boundary layer separation. Every time a student comes, he or she talks about boundary layers, and the next thing you hear is boundary layer separation. So we'll talk about boundary layer separation as well, with and without pressure gradient. And we will also talk about something called a thermal boundary layer. Some of you might be aware of that, so we will talk about that in a little detail, and how the energy equation comes into play, right? And finally, we'll wind it up by talking about Prandtl number dissipation in thermal boundary layers. So I would hope that by the end of this course, for example, say I have a flat plate. For example, I have a flat plate like this, right? And say I have a flow which is coming from this, right? And this is impinging onto this flat plate. So the questions I would like to ask is that, so how does the boundary layer develop on a flat plate like this? How does it look if I go along this edge of the plate? How does it look if I go along this edge of the plate? And how does it look if I go away from the plate, right? So say this is 1 meter length, right? So if I were to go from here to half the length, right, what would be the thickness of the boundary layer in this direction? How would the boundary layer look like if I were to travel this way along the plane, right, and along this plane? And what kind of effect would that have, right, on the flow itself? Okay, so by the end of this course, hopefully we shall have a conceptual understanding of what exactly we're talking about in terms of boundary layers, and also we will be able to do the math with which we can quantify the effect of the boundary layer. So I hope to see you there, okay, and hope we'll have fun learning things about the boundary layers. Thank you.